I know the recordings are kind of rough. People ask questions. I go on tangents a little bit. But anyway, we're going to talk about net ionic equations. In general, a lot of times they're double displacement, but not always. But double displacement is what, so especially in Chem 1A, you're going to learn other kinds, right? But in this class, I'd like to teach you the double displacement net ionic equations. And there's a set of steps for these. So let me write the steps. And I did this, again, in the lab, but I want to do it in here, and then I want to apply it to some other types of net ionic equations. So I'm going to make it more general. I'm guessing people will say things if they have questions, or you can type questions too, whatever you need. Looks like everyone said hi, or a lot of people said hi. So I'm just getting into it here. So net ionic equations, we're going to talk about it in a more general sense than in lab. We're still going to do double displacement though. So the steps are, and I'm going to write my favorite equation because it actually goes through all the steps. And the first step is actually one of the hardest, which is you write aqueous reactants. So in general for us, we're going to probably, all of our reactants will be aqueous, but I'm making this more general so it will also apply to Chem 1A, which you'll take later. So because if something was not aqueous, you can't write it as ions, right? Aqueous reactants as ions. And so let me go through the example again, was calcium chloride and silver nitrate. So I need to break these apart into ions. And I put a star. This is actually one of the hardest steps. It's a reverse of the naming skill. So in a sense, you can reverse the charges. There's a 2 here, so a 2 goes up there, and calcium is 2 plus. We might also remember that because it's in the group 2A. And then there's a 1 here, so the chloride's -1. And then the 2 is actually in front. Technically, there's a 2 in front. I can put it in front or not. Let's put it in front. It doesn't actually matter. I'm just gonna, it's just there. But I have to, this is an important skill. I have to break this apart and recognize it as 3 different things. It's 1 calcium and 2 chlorides. What I see a lot of people do, maybe I shouldn't show all the pitfalls that you can go through, but what I see is people will write Ca 2 plus and then Cl2 2 minus. They'll just break it apart at the metal and non-metal interface. But this is not true. You should not do that. You should be able to do this down here. Super, super important. Also, another reason why I like this one, we have a polyatomic ion. So what I see a lot of people do is they'll break this into nitrogen and 3 oxygen. You have to remember that that is one thing. The nitrate will separate from the silver. And so those are the ions. So that's the hardest step, actually, or one of them. And the next step is also a hard step. And I think the rest of the steps are pretty straightforward. The second step says switch partners. There's actually only one way to switch partners.
Sure.
Question?
Yeah, could you zoom out just a tad bit? We're getting cut off at the very end of it, the equations.
Oh, like that? How about if I just move the paper over? Is that better?
That's perfect.
Okay. All right. I actually lowered the camera, and I find the writing is easier probably for you guys to read now. I found a lower mount. I like the camera, actually, because I can write. I don't, if I'm typing in the Zoom, they don't let me do superscript. And so it's easier to do chemistry notation. Anyway, we want to switch partners. And there's only one way to switch, which is a metal, a positive charge has to go with a non-metal negative charge, right? And another really important thing about switching partners is the net charge. What does the net charge have to be when I make a new compound? Anybody? You can type it if you're, the net charge has to be 0. So we learned that back when we did naming, I believe. Yeah, good. Someone said 0. That's correct. Okay, so who goes with who here? What have we got? So I guess that's the first thing. Calcium is a metal. It's going to go with it, the nitrate. It was already with chloride. That's boring, right? And silver's going to go with...
Move the paper up a little bit, please?
Oh, like this?
Yes, thank you.
Okay. You guys have smaller screens than I have. You know, you can expand out your camera screen. You can drag out the corner if it's... but okay, I can move it too. All right, so how will silver and chloride go together? It looks like it's +1 and -1. I'm going to write the metal first, Ag and Cl. It's just 1 to 1. When I combine the calcium with the nitrate, it's +2 and -2. So I'm going to need 2 nitrates. It's just like what we did when we did naming. It's the same skill from naming as before. And when I do 2 nitrates, I have to use a parenthesis. Remember that 3 is the number of oxygens. It's not the number of ions, right? So I have 2 of those nitrates. Okay, so that's the, if I bring the light over, maybe it'll focus better. Okay, I'm sorry it's pulsing like that. But it is actually, it's a much better camera than the other one I was using. It has, at least it does focus. Okay, so those are the hardest steps, and I went through them quickly. But you guys want to check yourselves on these steps. This is where the students get messed up. They get messed up breaking it into ions, and they get messed up putting it back together into correct formulas. Those are the most key steps. The next step is balance with coefficients. And this is a regular step. This should be, and we did balancing, actually just worked on that on Monday. Balance with coefficients. So now I want to write the whole thing. So I'm going to write the reactants, calcium chloride, and these guys were aqueous. They were provided to me as aqueous, and silver nitrate, AgNO3 aqueous, goes to C, let me bring it up, sorry. CaNO3 2 plus Ag, let me move that over a little too. Okay, like that. Cl. And so I'm going to balance with coefficients. I'm going to look at the silvers are 1 and 1. The calciums, do the metals first, right? Calcium's 1 and 1. And then I guess I could do chloride. There's 2 chlorides there, and there's 1 chloride there. So what I will do, I hope red's okay. This is probably a better red than I was using last time. It stands out pretty good. I'll put 2 to have 2 chlorides, but now I have 2 silvers. So I'm going to go back. I have 1 silver here. I'll put a 2. And then that actually ends up balancing the nitrates. Now I have 2 nitrates and 2 nitrates. So this is a balanced equation. The next step I actually break into several parts, and I did not do that in the lab lecture necessarily. So this is where I want to go more general. So maybe instead of a star, let's put a little triangle. This is where it gets more general than last time. I'm changing things a little bit. And so step 4 is still the same basic idea, which is find the states of the products. But I want to introduce some ideas here. So there's actually 3 kinds of things we can do. So A, we can use a solubility table. Did I bring up a solubility table in the lecture on Monday? I can go back and show one if you need to see it. So a solubility table basically can tell me if ionic compounds, which is a metal and a nonmetal, right, together, are aqueous if they're soluble, or solid if they're insoluble. I think we looked at the solubility table last time. Nobody's texting anything or chatting anything, so I don't know.
Yes, you went through that one.
Okay. So I'm not going to show the solubility table, but I'll mention the cases when they come up. Is that okay? But
Yes.
you on a test, I will give you a solubility table because I don't expect anybody to memorize that. I know a lot of it, but I actually haven't memorized all the cases myself, and I've been doing this for a while. A solubility table is kind of complex, and it's not. Anyway, so we can use that. But now let me have some other cases here. Case B is a special case. If I have an acid and a base, then my products will be water and an ionic compound. And if I have an ionic compound, well, guess what I can do with an ionic compound? I can take it to the solubility table and decide, is it aqueous or solid? Is it soluble or insoluble, right? What's the state of water? Anybody?
Liquid.
It's liquid. Aha. Okay, that's important. And also, so for our purposes, an acid is something that has hydrogen on the left and a nonmetal. And a base is something that has a metal or a cation and then a hydroxide anion, right? And they will cross and make water and then an MX, a metal, nonmetal ionic compound. All right, so that's one case. And I can do an example of that actually if we'd like. There's a third case, which is gas forming. And I mentioned gas forming reactions when I went through the types of reactions, I believe, on Monday. And so for gas forming, in a sense, you want to memorize. And for our class, there's one kind I want you to know. Let me get another piece of paper and move this. Okay, so one kind, and the one kind that I find really, really exciting is metal carbonates. When a metal carbonate reacts with an acid, you get water, liquid, and CO2 gas, and oops, I got 10 minutes, it looks like. And that's okay, this will be good. We're at a good pace. Would someone though tell me when we get to 1 minute left? Okay, and then we'll start over, and this will be a block that I've recorded and I can upload it later. I'm a little bit behind because the uploading takes a little while. But anyways, when a metal carbonate reacts with an acid, we'll get water, carbon dioxide, and let me move that over a bit, an ionic compound. Okay. So in a general case, that would be an MCO3 plus an HX would go to water, carbon dioxide, and MX. And so I'll do one of those. But at any rate, when you're trying to find the states of the products, you want to look, say to yourself, okay, did I have an acid and a base? Or did I have an acid and a metal carbonate? If those cases aren't true, then I'm only going to look at the solubility table and decide if the products are solid or aqueous, okay? So let's actually, if we look at this one here, the one I chose, calcium chloride was aqueous, the reactants were aqueous. What about calcium nitrate? That one is going to be aqueous. So I could remind myself that that's because NO3 minus is always soluble, right? And that comes from the table. You can look on the table. If I look at this one, silver chloride is actually forms, let me move it, I hope that's over enough, forms a solid. And that's on the, I would also get that information from the table. Chloride is usually soluble, but not with silver. Okay. All right. So when I get step 4 done, that's actually really cool. When I'm done with step 4, I technically have a balanced equation, which is a neat thing. But we're doing net ionic equations. We can actually go further. This is a lot of detail. So you guys want to, I'll post this up and you can watch it later if you need to, and practice. I would practice, practice, practice. Okay, but we can go further than that. So let's take we have a balanced equation now. We found the states and we balanced it and everything. The next step, this is a long step, 5, is write all, let me put it up higher, aqueous compounds, compounds as ions. And then I'm going to put a little comma here. Solid, liquid, gas as is. So if I form a solid, liquid, or a gas, I cannot separate them into ions anymore. Those are molecules, and they don't break apart. Like water. Once I form water, water's not going to break back apart. Once I form carbon dioxide, that's a gas. That's not going to break back apart. Liquid, and okay. So let's actually do it with, let me rewrite the equation down below here, and then we'll break it apart. And once we've done this, we have what we call the total ionic equation. I don't know if anyone took high school chemistry. Sometimes the chemistry teachers in high school call it the gross ionic equation. I don't know if anyone assimilates or remembers or had that experience or not. Or maybe your teacher just called it the total ionic. But anyways, let's show the regular balanced equation first. Let me bring it up more. Calcium chloride aqueous plus 2 silver nitrate aqueous goes to calcium nitrate aqueous plus 2 silver chloride solid. So I'm going to, all the ones that are aqueous, I'm going to break that one apart, that one apart, that one apart. I'm going to leave that one as is. It does not break apart because it formed a solid. So this one gets broken apart as, and I'm doing this rather fast, I know, but maybe it's not super fast. Calcium, and I'm going to write aqueous for each. The ions, once they're, so when they're together, no charges. But when I break them apart, I need to show the charges and the state. Calcium ion aqueous, 2 chloride ions aqueous. Again, it's the same skill we had breaking it apart from step 1. Now the silver nitrate, now I have 2 of them. So that's actually going to give me 2 silver ions aqueous and 2 nitrate aqueous. The calcium nitrate's also aqueous, so it can break apart. It can break apart to calcium 2 plus aqueous and looks like 2 nitrates. 2, let me bring that up. NO3 minus aqueous. And then plus, this one doesn't get broken apart, so I'm just going to leave it. 2AgCl solid. Okay, so that's step 5. Step 6, cancel out spectator ions. Okay, and these ones are probably aqueous on both sides and the same amount, same style and amount. Okay, so actually, let me do this one. I'll do the things I'm going to cancel out. I'm just, instead of rewriting this all over again, let's just cancel out in red, right? What cancels out over here? Anybody? What's the same on both sides? What's aqueous on both sides? I see calcium.
Calcium.
Okay. Calcium cancels. And actually chloride, chloride's, someone said chloride. Chloride's aqueous here, but it forms a solid. So that one doesn't, but yes, someone said NO3 minus. So yeah, I have two NO3 minuses here and two NO3 minuses there. So that, gone. Okay. So step 7, right? What's left? And cancel out common denominator if necessary.
You have less than a minute.
Let me bring it up. Sorry. Necessary.
You have less than a minute.
Okay, thank you.
I think you
Let
have a
me-
minute and 40.
I'm gonna go till the time burns out. So what I'm gonna do, this one has a common denominator. After canceling, there's 2 chlorides, 2 silvers, and 2 silver chlorides. So I'm gonna strike out the 2. So my blue is what's canceling, okay? And then writing what's left, 8. What's left equals the net ionic equation. And so that is when a silver ion finds a chloride ion, aqueous, aqueous, they form silver chloride solid. So that's one set. Okay, and we're gonna run out of time. I'm gonna end here and we'll start up in just a second. And this is good too, because I get to end the recording.